Okay, it says use a net to find the surface area of each prism. What I'm going to do instead, we kind of really haven't been focusing on the net aspect of it, although what a net is just kind of a flattened down onto a single surface, all of the different surfaces. So it's like if it was a cardboard box and you sliced all along the edges and you laid it flat. Like figure out the surface area of that. So what we're going to do for this first one, number 7, is we're going to look at the 3 different measurements, 19, 29, and 6.5. And let's take let's just do this first surface on the front. You can see that this front surface and its corresponding back surface as well would be 19, with the cross, by 29, that height, right? And of course, because we have it front and back, we're going to have it twice, so we multiply by 2. Okay. Let me erase those marks, and let's do it again. We can say now, if we had this side surface here in pink, and this other corresponding side surface over here, we would get a 6.5 measure here by a 29 measure here. And of course, we're having that twice because it's on 2 sides, so we do it times 2. And finally, we can take the top surface here and the bottom surface. So we've got this bottom surface here, this top surface here. And what do they measure? Well, they are 19 across by 6.5 this way. So you have 19 by it like this by 6.5 like that. Okay? And of course times 2. Now, the net effect of this is that we've got all 3 of the measurements. You pair them up in all of the 3 possible combinations. You do 19 times 6.5, 19 times 29, and then 29 times 6.5, right? And you do each of those twice. So we can calculate this out and sum them up. And I'm going to do this on my little core function calculator here, just so I don't make any mistakes. 19 times 29 times 2. And I get 1,102. And do the same thing the other direction, 6.5 times 29 times 2 to get 377. And then we will do 19 times 6.5 times 2, and those are the 2 smallest measures, the 19 and the 6.5, so we're going to end up with the smallest of the 3 numbers here, 247. And then we just need to sum them up, 247 plus 377 plus 1,102, and we get 1,726. And what are the units? The units were centimeters. We're talking about surface area. So we will say it is 1,726 centimeters squared. Okay. And we will do that one more time. But actually, when I say one more time, we're going to do it for number 9. And we do this. Now, track with me, if you will. This length right here, okay? We're going to need to calculate that out. The reason we're going to need to calculate that out is because we can do this. We can find the area of this triangle, okay? And double it because we'll have that area back at there too. And then to find the lateral area, what we're going to do is we're going to take the perimeter of this times the height, okay? And if you're in class, you'll see how if you wrapped a piece of paper around the surface, the piece of paper's width if it has exactly the perimeter and its height has exactly that, then it will perfectly cover this because this is essentially 3 surfaces that will lay flat as you unfold it going around. So it would be the perimeter times that height would give you that lateral surface. So let's do this in two pieces. Let's first find the green triangle. Okay, so we've got the area of a triangle is 1/2 base times height, and it's 4 times 4. And notice that we're going to get that times 2 because there's 2 of those triangles. And that has the effect of this 2 times this 1/2 becomes 2 times 1/2 is 1. And the reason that you're taking 1/2 here is because you've only got half of the triangle. But if you were to then fill that in and say, well, what if I took the triangle on the back and made that, filled in that same equal space right there, then you would just get the rectangle of length times width. So that's how we're going to deal with this. And we say, okay, then we get an area of 16 inches squared. And that's just for the end bases. Okay, so I'm going to put that as a partial value down here. 16 inches squared. I'm going to erase the rest of this. Now, let's get all this junk out of here. If we have the 2 legs of an isosceles triangle, and what we're talking about is this leg here, let me do that in a different color, this leg here, and this leg here, okay? And it's isosceles, so they're both 4, then we've got a 45, 45, 90 right triangle. And that would make this outside length, or this final length, 4 times the square root of 2, okay? Why does that matter? Okay. What we want to do is we want to use the perimeter times the height to find the lateral surface. And the lateral surface is like all of this, all of that, all of that. Those 3 sides that wrap around that are not the 2 parallel bases. Okay, so you take the perimeter times the height. And the perimeter, what we've got is 8 plus 4 root 2. 8 plus 4 square root of 2 is the perimeter around that triangle. And we can't add those together because the 8 isn't being multiplied by root 2. So that's going to be, you can't just say it's 12 root 2 because that doesn't say 8 root 2. So you can't add them together. It's a little bit like having a constant and a variable term, even though it's technically not a variable, but it is a thing that you're multiplying by 4. You're saying we have 4 times that amount, root 2, and that's not what 8 says. It's not 8 times some other amount, it's just 8. So anyway, that's the perimeter, and we multiply that by the height, which is 8, and so when we distribute it through, we get 8 times 8 is 64, plus 8 times 4 root 2 is 32 root 2. And then, of course, the 64 and the 16 from down below have to get added together. I'm going to get rid of that now that I have it up there from below. And what do we get? We get 80 plus 32 root 2. That would be the exact answer. And then, of course, it's inches squared. That's the exact answer if you didn't want to round it off and you wanted to have a perfect exact answer. And I think that it's clear at this point that the radicals are only able to be represented exactly by keeping them as radicals and not turning it into a decimal. Anyway, if you calculated that, let's see, 32 times square root of 2 and then plus 80, it would become about 125.25 something. So we can call that, if we wanted to, we could say or, because it didn't ask us how you wanted to do it, we could say 125.254, let's say 0.3 inches squared. And that's how you do all this. So I'm going to box that answer. Either one of those answers is acceptable. Yeah, that's how you're going to do it. I don't know if you have any additional questions, you can just ask me directly in person.